types of antibodies that can be used. This is a fragment of an antibody that has better distribution within a cancer compared to a whole IgG. The advantage of a whole IgG is that you have a better circulation time, and that's the pharmacokinetics shown here. So the antibody will circulate for 1 or 2 weeks as compared to the fragment of the antibody that is excreted very quickly. The advantage in the small antibody, though, is that you have improved biodistribution within the tumor. So these are images of the antibodies to our inducible antigens TIP1 and GRP78 following irradiation of a human lung cancer. And in our pancreatic cancer model, you see the same type of result where we get specific binding to cancer in mouse models. Again, the goal is to bring this into clinical trials, so we would image the anti-GRP78 antibody with I-125, which is an internal emitter that we can image during the clinical trials. So this would require either SPECT or PET imaging for the planned clinical trials. And the final example that I'm going to give you, which complements each of these different technologies, is thermal regulation of drug release, that is, using hyperthermia to activate the release of a drug. In that schematic, first, we are planning this clinical trial using high-intensity focused ultrasound, which is the acronym HIFU, and its MRI guidance. And the general concept is that in a standard MRI imaging system, you focus ultrasound to a focal point, and you get hyperthermia in each of these focal points, and then you rasterize the movement of the focal points throughout the tumor to elevate the temperature. And there's two different approaches. You can either use ablative high temperatures or hyperthermia doses that can enhance drug delivery or enhance radiation sensitivity within a cancer.